Alright, so we left off after question 46. Now we're doing question 48 by popular demand. Where in the world is my black pen? Oh well, we'll just use a red pen of death. You'll never notice. Question 48. What in the world? Oh, that's nice. Somebody put gum on my floor. Sorry, I'm trying to take care of somebody's stupidity. Okay, question 48. Determine the limit as n goes to infinity. I told you that you should always, in these rational functions, you should look at the largest power of n in the top and the largest power of n in the bottom, or reduce it. That reduces to a nice negative 1/3. Okay? And since it reduces to, there's no n in the top or the bottom, that is the limit, that is the value that it converges to. Which describes all the solutions to tangent x equals 1. This is question 49. I'll back up here for a second here so you can see. Tangent x is equal to 1. Well, keep in mind on the unit circle here, where is the tangent equal to 1? It's equal to 1 right here at pi over 4. And then also 5 pi over 4 on the other side of the circle. So we want to jump around, we want to start at pi over 4, and we want to jump around the circle in increments of pi, right? Because as you come around here, you're jumping around half the circle, so you want to jump around the circle in increments of pi. Well, let's look at our choices here. So for D, it says start at pi over 4, but it jumps around the circle in increments of 2 pi. That is skipping one of my solutions. This one starts out both at the top at pi over 2 and at the bottom negative pi over 2, and then jumps around the circle in increments of 2 pi. That is definitely wrong. A and C both start at pi over 4. This one starts at negative pi over 4 as well. And clearly there's nothing down here at negative pi over 4 because that has a slope of negative 1. So the only possible choice here is this one, and clearly it shows that you're starting at pi over 4 and you're jumping around the circle in increments of pi. Any integer k could be positive or negative, which means it could go in either direction, but it's going to hit every single solution that has that same tangent value. In the circle, question 50, in the circle of radius 15, how long is an arc with a central angle of 5 pi over 6? We talked about part over whole equals times, let's see, arc. Okay, so that's 2 pi r. And in this particular question for us, we've got 5 pi over 6 divided by 2 pi radians times 2 pi with a radius of 15. Obviously, these 2 pi's are going to be canceling out, so we really need 15 times 5 pi over 6. 3 obviously goes into that 5 times, and 3 goes into that twice. So 5 times 5 makes 25 pi over 2. And 25 pi over 2 is choice D. Let's see what's next on my list. 58 is next on my list. And then I've got 61 through 64. 66 through 70. I'm just circling problems that I need to do. 66 through 70. 74. 79 through and 80. 79 and 80. Okay. 87 and 89. And 99, 100. Whew. I'm going to be working here. And 102 to 104. Oh, man. Giving me a serious workout on my trigonometry skills. Question 58, how many permutations consisting of 4 letters, each starting with a letter B? Okay, how many permutations consisting of 4 letters, 1, 2, 3, 4, each starting with a letter B can be formed from the letters of the word rubble? Okay, so we could use the letter B there And then how many other letters do we have left? Okay. So let's see here. 1, 2, 3, 4, 5. So 5, 4, and 3. How many choices is that? 5 times 4 times 3. Isn't that 60? Okay. Obviously that's one of the choices, right? But what if it's the other letter B? Okay. So in other words, there's two letter B's. So that's going to give me times 2, or 120. 120. Okay, so 61. Find the components of the vector rounded to the nearest tenth. Okay, so here's the picture. Components. So we're really looking for the x value and the y value. So obviously x is going to be positive and y is going to be negative. We are looking at 55 cosine 41 and 55 sine 41. Now, the calculator is not going to tell me. Now, I do need to have my calculator in degree mode, otherwise this is going to go down in flames. So please make sure your calculator is in degree mode, and if it is in degree mode, then we're in good shape. So 55 cosine 41 and 55 sine 41. Okay? So these are the two values. Keep in mind the second one has to be negative. So 41.5 41.5 comma negative 36.1. Oops, there they are. 62, give the polar form and the compass directions for each of these. I did record this in another video, so I'm going to skip over this one. I don't know if I can find it really quickly. Possibly from a previous video. Yes, this is a third quadrant, three to the right, one down. So you're in quadrant 4. Sorry, and you are using the Pythagorean theorem to find the radius, right? 3 squared plus 1 squared, and you're also doing inverse tangent of opposite over adjacent, which is the 1/3. And you get the 18.4 degrees. Now, if you take 360 and subtract that 18.4, that's going to give you the actual direction of the vector in the positive rotation there. Obviously, it's radical 10 or 3.16 if you need a decimal. That's the radius, and this is the degree measure of the angle. Now, in terms of compass directions, radical 10 is obviously the units of the vector. And then 18.4 south of the east direction. And 62b, very similar type work. You're dealing with the Pythagorean theorem, right? 4 squared plus 5 squared, and take the square root, you get radical 41. Inverse tangent of 4 over 5. Don't worry about the negatives. The negatives aren't really helping you that much, because when you do the inverse tangent of 4 over 5, opposite over adjacent, you end up with 38.7 degrees. Let's see if I can back up a little bit so you can see more of this. And then, so that's going to come in handy for my compass directions, radical 41 units, 38.7 degrees south of west, since this is the west direction and this is the south direction. In terms of the polar coordinate, obviously radical 41 is the radius from the Pythagorean theorem. We are in quadrant 3 here, so we take that 38.7 and we add it to 180. And that's how we get the 218.7. We add it to 180. So that's question 62. 63, give the component form and compass direction for the vector. Similar type stuff here, so I think I'm going to skip this one. Yeah, you're talking about the radius and this. Just draw yourself a picture. 55 degrees. It's got so we know what the picture looks like, and then we're talking about finding x and y. The In terms of compass directions, you're talking about 6 units, 55 degrees north of east. And then, of course, x is going to be equal to 6 cosine 55, and y is equal to 6 sine 55. And both of them have to be positive because you're talking about quadrant 1. Question, and you can get the decimals on your calculator. Give component form and polar form for a vector describing the path of an object that went 16 miles north of west. 16 miles at 30 degrees north of west. Okay, so 30 degrees is in here. Components, just keep in mind your x value is going to be negative, so even when you do this 16 cosine 30 and 16 sine 30, just realize that this is going to be a negative number, even though the calculator is not going to spit out a negative for you. And then in terms of your polar form, you've got, polar form should be pretty easy, right? They gave me the radius. Thing you have to figure out maybe is the angle measurement, but if it's 30 degrees, then that's going to be 150 degrees. So this is a lot simpler than you think in terms of changing it to polar form. I did talk about in class how that should be 3b plus a, not 3c plus a, because the answer wouldn't match. Okay. Whew. I'm about to go get some lunch and come back to this in a little bit. So hold on to your hats for question 66. That'll be next on my agenda.